I apologize you can't see me. I do not know why my camera will not turn on. But I work in the regional office at the GAC at North Ops and Reading as a fire analyst. And I do a lot of different roles there, but one of the roles that we fill in predictive services is trying to support wildfire and prescribed fire and all the different things that revolve around weather. And as a fire analyst, I work with our meteorologists to support kind of weather related products that aren't necessarily forecasting. So the meteorologists are really into forecasting, but the other stuff around weather is the stuff that I kind of help do the analysis for. And one of the things we built a few years ago was a drought tools paper. And so I'm going to start sharing my screen. I've got a little PowerPoint for us today to talk about drought and specifically how it affects fuels and prescribed fires. So hopefully this works. There we go. All right, it looks like it's working. So that's excellent. Can you guys see the slides?
Yep, sure do. It looks good.
Fantastic. Fantastic. So drought and drought indices for RX planning. So there's just a quick brief for the topics. We're going to talk about what drought is, the scales that drought happens at, its impacts to prescribed fire, and then the real meat of this is like those indices and the resources that we can have to assess drought. So moving on to that, like we have the conventional definition of drought. This is the traditional way that people have thought about drought for decades, right? And it's both of these definitions are very similar. One comes from the National Weather Service, which actually is the one on the bottom, is almost word for word the Merriam-Webster definition of drought. And then the NWCG glossary has a definition of drought. And the big thing that these both focus on is an extended period and dry and a deficiency in precipitation. So they're very precipitation focused and they're very long duration over a large area. But we also have something a little bit more, it's not new in its occurrence, but it's a little bit newer in our recognition of it and its impact on things. And that's a flash drought. And it's a more rapid onset or intensification of drought. The big key, and I know you guys can read the definition, so I'm not going to read it word for word. The big key here is the time frame. It happens really fast, and that it involves things other than just dry weather. So a flash drought, that's that combination of really dry weather, but it also typically has really high temperatures, often winds, high solar radiation. So it happens in the summertime, and it has similar impacts to a drought, but it can come on really quickly. And you may not necessarily have had a long, prolonged period without rain. And so we'll just compare those a little bit here on this screen, bullet for bullet, where you can see flash droughts on the right, on the left, long-term drought on the right. And that long-term drought is that more traditional, right? It's slow, it's months to years, purely precipitation deficit. It lasts year round. Flash droughts, rapid onset, can occur in weeks to months. You have a precipitation deficit with some other condition, and typically only really a thing during the growing season. This year in California was an absolute beautiful example of this in the first 2 weeks of July, and then again the first week or so of October, end of September into early October. Both of those are on the heels of a moderately wet winter, not horribly wet or dry, pretty average, and then long-term year over year, we had really wet winter last year. So we have a really wet winter followed by a somewhat average winter and a moderately average spring. And then last fall, we had early season precipitation and multiple precipitation events going into our winter. So in that traditional classical sense of a drought, we really weren't in one for most of this summer. But those first 2 weeks of July had incredibly rapid onset of extreme heat, very low humidities, and an extended period without rain. Now in California, an extended period without rain in the summer is totally normal. But the flash drought that occurred really set the stage for some rapid fire growth, things like the Park Fire on the heels of this flash drought scenario. That's the combination of a period without rain and those other events, really strong solar radiation in the summer and extreme heat for an extended period with really poor humidity recoveries. So you get that flash drought that dries our fuels. And so those are the two types. Both can have really big impacts for fire behavior, and anything that can impact fire behavior really impacts our planning in both, in fuels work and prescribed fire. So really important to think about these because none of the fuel modeling that we do when we're planning for prescribed fire can foresee either of these, especially when we're planning for a burn 2 years, 3 years out, right? Like you don't know if you're going to have a long-term drought. You really don't know if you're going to be trying to burn on the heels of a flash drought. So like anyone doing prescribed fire right now in pretty much anywhere in the Western United States has dealt with a recent flash drought. It's not as extreme as in the summer because we are kind of not in the typical peak growing season right now. So it's on the edge of that flash drought definition, but we've been setting ERC records in some places year-round records, not just daily records. And that's across the Western US. We've had lots of wind, really drying out our fuels. So, your fire modeling, your fire behavior stuff that's in your burn plan is probably not accounting for the conditions that we're experiencing now. And so you have to really think about those questions. How have these either long-term or flash droughts impacted the fire behavior that I'm expecting when I'm going to do a prescribed fire? So we have some good impacts here. The flash drought on the left, you can see rapid is the first word in the first 4 bullets. So it's quick changes. Things are really different from how they were just a week or 2 ago. It can really impact your fine fuels. Really has a strong impact on live woody fuels because that air is really sucking moisture out of those. It can lead to really rapid transitions of live fuels from being not available to available. Really rapid carrying over herbaceous fuels similar to the fine fuels. And then those 3 first bullets kind of line up into that 4th bullet where you have that full flammability of your fuel bed can go from not being available to being available very quickly. Sudden changes in flammability. Our long-term drought is a steadier increase, right? A really strong thing that we see is that increase of dead to live ratio as things die over time from prolonged lack of moisture. Our heavy fuels or deep duff are really impacted by long-term drought, right? Things that may not be impacted by flash droughts. Large 1,000-hour, 10,000-hour, 100-hour fuels, deep duff. Low foliar fuel moisture in trees really is something that we see more in these long-term droughts. Things that are deep-rooted can access deep soil moisture, less impacted by soil by flash droughts, but really impacted by long-term drought, where you have much easier transitions into crown fire behavior in timber fuels, where you have really stressed trees over a long term, and those foliar fuel moistures are much lower. Things that appear green, live fuels that have been stressed for year over year, are still available to burn, even if they look like they're not. Okay. And then the overall flammability is during a long-term drought is even more sensitive when you layer a flash drought on top of it. We saw this in the early parts of this decade in 2020 and 2021, where we're coming on the heels of really long-term droughts, and we layered summer flash droughts on top of them. So those are the comparisons of droughts. Those are some of the impacts. And now we're just going to transition into the tools that we use to look at drought. One of the main emphases of the newest Forest Service burn plan is that, question about drought on your, element 2A and 2B, right? Are we in a drought that changed things that are different from the conditions when you wrote your burn plan? So the classic, the go-to is the US Drought Monitor. This thing is updated weekly on Thursdays. So if you're using it Tuesday, Wednesday, it's a little bit stale. Like if you had looked at the drought monitor the day or two following Hurricane Helene last week, the Southeast was still in drought. And actually, you can still see on here, portions of the drought monitor are still showing drought that maybe won't in another day or two when they get their update tomorrow. So that's something to think about with this product. And this is not a statistically derived model. This is an expert panel, right? It's a blend of many inputs, models, and variables. So they have a series of climate, weather, and agricultural experts who provide input into this, and they rotate who the lead on the project is every month. And it's folks from the National Weather Service, the Climate Prediction Center, and U.S. Department of Agriculture who are involved in putting this out. They attempt to capture short and long-term drought. You can see how they have the S and the L on there, looking at like the short-term or the long-term hydrologic versus agricultural type droughts. So that's captured on here. This is a great product. It's probably what most people use. I would suspect it's what most people use when they're assessing drought for a prescribed fire. It's accessible in a lot of different places. It gets linked through a lot of different websites. It's linked on both North Ops and South Ops GAC web pages on the weather page. I have a links slide at the end of this presentation that has the link in it to the US Drought Monitor, and I'll drop that PowerPoint into the chat when I'm done so you guys can all get that. Quick Google search for US Drought Monitor brings it right up. That's really the standard go-to. And like I said, the things to consider with this one are its update frequency and being able to explain to your leadership what it is and what it isn't, right? Like that this is not one specific model or one specific product, that it is a blend of things with expert opinion put into it, collaboratively used to draw the drought levels across the country. Another cool thing about this product is it does include things other than the continental US. A lot of our products, and obviously we're in California, so not a huge concern for a lot of people, but this product does capture Alaska, Hawaii, Puerto Rico, Samoa, like a lot of places. So this is a product that really captures a bigger swath of America. A lot of our products that we have available to us are continental US only. So in California, they're all available to us, but if you're traveling, the US Drought Monitor is available across the entire country. A companion to this are the drought outlooks. They have a monthly and seasonal outlook. These are the current ones, built the same way with the same group. And these take that drought monitor and say, do we expect drought to persist or to improve, or a place that's not in drought to develop? So the monthly outlook is just the next month. They come out. So this is the October version. There'll be a new one at the end of October for November. And then these are for like a 3-month outlook, October, November, December. So the seasonal outlook is a 3-month. The monthly outlook is just the next month. So that's valuable. We have to answer that question on our burn plans, what is coming. And it's also really valuable if we have long-term or landscape level type projects where we're trying to see, you know, we're going to be doing this project for a week or 2 weeks. What do we see coming in the future? Not just what are we doing now, because we all know it's sometimes more about what have you done for me lately than where are we at right now today. So that can be pretty valuable to us. The next thing that we have is Evaporative Demand Drought Index, or EDDI, EDDI. It's a measure of the evaporative demand or thirst of the atmosphere compared to historic normal. It comes from 4 observations: surface observations, temperature, humidity, wind speed, and solar radiation. What you'll notice about this is that those inputs do not include precipitation. So this is a measure of how much water the atmosphere is pulling out of the plants, not capturing how much recent precipitation you've had. So if you are really hot and dry and you have a lot of solar radiation, or you're windy and you have a lot of solar radiation and it's warm, this will show a pretty high number, or can show a high number. And that impact may or may not be significant to you. If you have a really high EDDI value and you have very low soil moisture, your plants are going to suffer. If you have a high EDDI value, but you have good soil moisture, you may have a lag time before that high EDDI value results in true impacts to your fire behavior and your overall fuels profile. So you have to think about what this is telling you, and that critical part of this particular one, this index, is that it does not include recent or any precipitation. So like I said, this one is compared to normal. So you can see it's, you know, percentile based, and it scales from high drought categories based on the percentile to you know, wetness categories based on percentile. Like you're way wetter than you've ever been. So if you're in that 70 to 30, that's your normal. You know, that's average. And for any given time frame, you can get EDDI in week or month categories. So you can look backwards over a lens of 1 week, 2 weeks. In this case, I'm showing you 4 week compared to 12 week for the same date. And this is just historical data, but you can see that where you draw your lens can really change how your drought picture looks. So for, you know, August of 2017, a 4 week picture made it look pretty wet in the Intermountain West. If you go to a 12-week picture, you're much less wet. If you get past 12 weeks, you start to get into that multiple month time frame where you can use Eddy to start assessing your long-term drought. When you use 4-week or shorter windows with EDDI, you can start assessing flash drought. And this is a really good tool for assessing those flash drought conditions, because you can look at it in 1 week, 2 week, 3 week increments and really get a picture for how long you've been in a drought, how stressed your fuels are really going to be. You can overlay that with when you had precipitation, and you can think about the combination of the evaporative demand from the atmosphere with how much soil moisture I have based on how much precipitation I received or didn't receive. So we use this a lot as a really good indicator of flash drought during the growing season at the GAC. Our meteorologists and our fire analysts definitely look at this. We look at the 2 week, the 1 month, and the 2 month increments the most to get a good feel for how things have been changing over time and an idea of where we're at for flash drought conditions. Here's an image, our current 1 week Eddy image for the country, and you can see just how strong that flash drought signal really is, and compare that to our drought monitor, which is, it shows drought across a lot of the country, but you're in those yellows and browns, which are like abnormally dry to very early stages of drought. Whereas when we look at a 1 week EDDI, we're pushing some of the driest conditions for this time of year that we've ever seen in terms of evaporative demand, because it is comparing it to normal and historical conditions. So you can see that, yeah, definitely, flash drought conditions are quite prevalent across California and much of the Great Plains and portions of the Intermountain West. So really valuable tool at that 1 and 2 week timeframes. Another thing about Eddy, similar to the drought monitor, is it's always got a little bit of a delay. This, the October 3rd is the image I have up here because it's a 5-day delay. So you can only look at, there's a 5-day delay between today and when the most recent EDDI is available. So it's not 100% up to date. There is that 5-day lag that you just have to consider when you're using this product. The drought monitor updates once a week. This has a 5-day lag every day. It's always 5 days behind the current conditions. And that's because they do a lot of quality checking on their data. They do quite a bit of looking at it to make sure that what they're seeing and what's coming out of the model is accurate. So they take 5 days to check data before it comes in and is available. So that's just something to think about with this product, that's part of how it's derived. KBDI is the next index we'll talk about. This is something that was developed specifically for fire. It's a measure of the cumulative moisture deficiency in your deep duff and upper soil layers. It's based on the amount of rain that it would be needed to return soil to full moisture capacity. It's really sensitive to your scaled by your average rainfall. So this is one of the reasons that in your RAWs, it's really in WIMS, it's really important that your station catalogs have an accurate annual average precipitation number, because it really impacts KBDI. This is an intermediate index that feeds your NFDRS version 4 indices. So all of your ERCs and BIs across the country now integrate KBDI as an input. It's not the only input, but it's part of it. And you can see where the Western US is obviously quite extreme on those KBDI values, and in some of the parts of Texas, some of it lines up really well with what you see in Eddy and in the drought monitor, and some of it doesn't. And that's because of the way this is calculated. Some places in the southeastern US use KBDI as an index to indicate fire danger or fire behavior potential straight. They just actually use KBDI. In the Western US, that's not as common a practice. It's tracking with fire activity is not as good as a standalone index, but it still has value as an input for our other indices. The best place to get this is the WFAS portal, the Wildland Fire Assessment System, that's run by the Missoula Fire Lab. So that's KBDI, and you can see all the little triangles on here are the RAWs that contribute to it. Again, it uses the inputs from the RAWs for precipitation and temperature, and then scales it based on how much rainfall you normally get there and how much rainfall you would need to get your soil back to full moisture. Okay. And then the next thing, excuse me, the next thing to look at is precipitation analysis. And I put this in here. It's not an index. There's no specific drought index. This is just purely precipitation. These graphs come from the Western Regional Climate Center that has some really cool precipitation and temperature analysis maps that look like this that will give you how much rain you've gotten, hard numbers, how many inches that is different from your average, and then what percent of average precipitation. And they have it at varying time scales from 1 week all the way out to like 6 months or something. What I've got up here is going back 60 days. Oh, excuse me. Going back 60 days on the left, and just the last 2 weeks on the right. And you can just see the big difference, right? If we look at percent of average precipitation for the last 60 days, it's dry in the south, but north ops, good portions of north ops are right in there in your average to above average. Now, keeping in mind that good portions of this time frame in August and September, it doesn't take very much rain to get above average because average is pretty low. But as we move into late September, early October, our averages go up, but our percent of average is really low, below 25% of average, solidly across the entire state of California. So pretty stark difference on percent of normal precipitation across the state, depending on what window you're looking at. And this is one of the things that you compare with eddy to get a good idea of, okay, if my eddy's high, but I have above normal precipitation in the last week, I still have a little time before my fuels are going to start reacting because there's good soil moisture. They're still sucking up moisture out of the ground. But if my precipitation is like this and my eddy is elevated, you're setting yourself up for some pretty potentially problematic fire behavior, whether that's a wildfire or your prescribed fire. So you start looking at, in a prescribed fire setting, how likely is spotting? How far is spotting going to go? What's the fire behavior going to be like outside my unit if I do get a spot? What's it going to do? Is it going to take off right away on me? Is it going to cause a lot of problems for me? Questions like that. And that's where you have to think critically yourselves and say, okay, I've done my analysis of my drought. Now, what does that tell me about prescribed fire operations? And that's what this next slide is, just kind of those questions, right? Because we have to think critically about this. We can do all the looking at indices we want, but if we don't think critically about what that tells us about operational work, it doesn't do us any good. So think about, will your surface fuels hold heat longer than normal? Are you going to have long mop up or short mop up, long smoke production, limited short smoke production? And it can go both ways. It can be so dry that your stuff burns up super fast, or it can be drier than you expected, so it holds heat longer. There's different things that come from that. And then, will the surface fire transition to the canopy easier? Are fuels more receptive to spotting than you expected? Will the mortality of overstory trees be higher than the models predicted because of that long-term drought or heat residence time? You need to look at those live fuels following a multi-day heat wave. Have they changed flammability? And then could that drought impact any other specific management objective in your operation, right? Because all of our prescribed fires have those really specific management objectives that could be altered by a drought slightly differently, because I can't predict all of the different things that you guys may or may not be using in your prescribed burn plans as your objectives, right? So think critically about how drought can affect those things. So there are the links. Like I said, I will drop the slides into the chat, and then also send them to Robin and Stephen in the Fuels group if anybody needs them. I think, that's it for me on that. I'll stop sharing and we can move into any questions folks have.
Yeah, appreciate that, Kev. That's interesting, especially that eddy part, because I really feel like that evaporative or the atmospheric moisture deficit is coming into play with some of these escape burns, and I think that's been a part of some of the things that we've seen too. So I hope people are paying attention to that one as well too. But I know we're about 40 minutes into it. Does anybody have any questions for Kevin? You got a good opportunity here to talk to somebody who knows what they're talking about with this stuff.
Kevin, I got one for you.
I have a question too.
I'm sorry, because I am mobile devicing on my way to coach hockey, but what's going on with the vapor pressure deficit? Is that factoring in? I've been seeing that getting a lot of airtime in research lately. I'm just curious if that's getting pulled into any of our like models or things.
Yeah, vapor pressure deficit is it's a lot like it's derived from the same inputs as relative humidity. Um, it's a better measure than relative humidity because it's an absolute number instead of relative. So you have a bigger draw on your plants at 50% RH at 90 degrees than you do at 50% RH at 50 degrees. So vapor pressure deficit is actually really similar to EDDI. The advantage of the eddy index is that it's comparing it to normal. So it helps give you some context, right? It's percentile based. So it helps give you a little bit more context about where you're at compared to normal. But yes, vapor pressure deficit, I think we have seen is all the research indicates that it's a fantastic measure, a better way to measure the moisture and the thirst of the atmosphere, how it's impacting plants, because it's a solid measure of how much moisture is being pulled out of the pores of your plants, right? Which eddy is very similarly going after the same thing, and it actually uses vapor pressure deficit as an input in eddy.